Episode 13, titled Classification Evaluation, Confusion Matrix Thinking Under Pressure. The goal is to turn confusion matrices into fast, correct decisions, because DataX questions often expect you to reason from outcomes rather than from memorized formulas. A confusion matrix is simply a structured way to count how predictions and reality line up, but under time pressure, it can feel like a blur of labels unless you have a consistent mental model. The exam rewards you when you can look at a matrix, understand what kinds of mistakes are happening, and select the metric that matches the scenario's harm and constraints. This is especially important because classification problems often involve imbalance, asymmetric costs, and thresholds that can be tuned, which means no single metric is universally best. In this episode, we will make the matrix feel like a story about decisions and consequences rather than a grid of numbers. When you can tell that story quickly, you will choose better answers, and you will do it with less mental strain. Before we continue, a quick note. This audio course is a companion to the DataX books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. A strong starting point is to define the 4 core outcomes clearly, because everything else in classification evaluation builds on them. True positives are cases where the model predicted the positive class and the actual outcome was positive, meaning the model correctly identified a target event. False positives are cases where the model predicted positive, but the actual outcome was negative, meaning the model raised an alarm that did not correspond to the event. True negatives are cases where the model predicted negative and the actual outcome was negative, meaning the model correctly dismissed a non-event. False negatives are cases where the model predicted negative, but the actual outcome was positive, meaning the model missed a real event. The exam may present these terms directly or describe them through scenario language, like flagged incorrectly or missed cases, and you should map that language back to these definitions. Once these 4 outcomes are stable in your mind, the rest of the metrics become simple ratios built from these counts. The matrix becomes meaningful when you tie each cell to business outcomes and operational costs, because that is how DataX expects you to choose metrics. A false positive in fraud detection can mean customer friction, support costs, and loss of trust, while a false negative can mean direct financial loss and exposure to ongoing abuse. In safety monitoring, a false positive can mean unnecessary shutdowns, wasted resources, and operational disruption, while a false negative can mean injury, equipment damage, or catastrophic failure. In churn prediction, a false positive can mean spending retention incentives on customers who would have stayed anyway, while a false negative can mean losing customers you could have saved with timely intervention. The point is that the same matrix counts can represent very different harms depending on the business context, which is why the exam does not reward metric selection by habit. When you can translate each cell into a cost story, you can identify which mistakes are most unacceptable, and therefore which metric should be emphasized. This is the leadership mindset DataX rewards, because it treats evaluation as a decision policy rather than as a technical scoreboard. Accuracy is usually the first metric people compute because it is simple, but the exam expects you to compute it and then question it under imbalance. Accuracy is the proportion of all predictions that were correct, combining true positives and true negatives over the total number of cases. The problem is that in imbalanced settings, a model can achieve high accuracy by mostly predicting the majority class and still fail at the task that matters. For example, if the positive event is rare, always predicting negative can produce impressive accuracy while missing every real event, which is operational. For example, if the positive event is rare, always predicting negative can produce impressive accuracy while missing every real event, which is operationally useless. The exam often uses this trap, presenting a high accuracy value and asking what concern applies, and the best answer typically points out imbalance and the need for metrics that focus on the minority class. Accuracy is not meaningless, but it is incomplete, and DataX rewards recognizing when it is misleading. When you treat accuracy as a starting check rather than the final conclusion, you align with correct classification evaluation practice. Precision is derived from predicted positives and correct hits, and it answers the question, when we predict positive, how often are we right? The numerator is true positives, and the denominator is all predicted positives, which includes true positives and false positives. Precision is a measure of how trustworthy a positive prediction is, which matters when false positives are expensive or disruptive. In fraud detection, high precision means most flag transactions are truly suspicious, which reduces wasted investigations and customer friction. In healthcare or safety triage contexts, precision can matter when interventions are costly, risky, or scarce because you want to focus resources on cases that are truly positive. The exam may describe a desire to reduce false alarms or avoid unnecessary actions, and that language often signals that precision should be emphasized. When you can connect trustworthiness of alarms to precision, you can select the correct metric quickly and justify it based on consequences rather than on memorized definitions. Recall is derived from actual positives and captured cases, and it answers the question, of all real positives, how many did we catch? The numerator is true positives, and the denominator is all actual positives, which includes true positives and false negatives. Recall measures sensitivity to the positive class, which matters when missing positives is costly or dangerous. In fraud detection, high recall means you catch most fraud cases, reducing losses, though it may come at the cost of more false positives depending on threshold. In safety monitoring, high recall can be critical because missing a real hazard can cause irreversible harm. The exam often frames this as minimize misses or catch as many as possible, and those phrases are strong recall cues. When you can connect avoid missed cases to recall, you will find it easier to select the best answer even when distractors try to redirect you toward accuracy or general performance measures. Specificity focuses on correctly rejecting negatives consistently, and it is often overlooked until a scenario makes false positives the dominant pain. Specificity is the proportion of actual negatives correctly identified as negative, meaning it relates to true negatives and false positives. High specificity means you are good at not raising alarms on normal cases, which reduces noise and operational burden. In environments where the negative class is the overwhelming majority and where interventions are costly, specificity can matter because even a small false positive rate can translate into a large number of false alarms. The exam may describe alert fatigue, overwhelmed analysts, or disrupted operations, and specificity becomes a useful way to express improvement in rejecting negatives correctly. Specificity is also useful when you want to describe performance on the majority class without relying solely on accuracy, especially in imbalanced datasets. When you remember that specificity is getting negatives right, you can interpret it as the counterpart to recall, which focuses on positives. F1 score, often spoken as F1 after you have said F1 score the first time, is useful when you need to balance precision and recall, especially when both false positives and false negatives matter. It combines precision and recall into a single number by emphasizing that both must be reasonably high to achieve a high score. This is valuable in scenarios where you cannot afford to over-optimize one at the expense of the other, such as detection systems where false alarms waste resources but misses cause significant harm. The exam may describe a desire for a balanced approach, or it may present a situation where accuracy is misleading and both kinds of errors matter. In those cases, F1 can be a defensible metric because it penalizes extreme imbalance between precision and recall. The key is that F1 is not always the best because sometimes the scenario clearly prioritizes one type of error over the other. DataX rewards choosing F1 when balance is truly the objective, and choosing precision or recall when the scenario clearly makes one error type dominant. Confusion matrix patterns can also signal threshold problems, and the exam expects you to recognize that many classification metrics change when thresholds change. If you see a pattern with many false positives and relatively few false negatives, that can indicate a threshold set too low, producing too many positive predictions. If you see many false negatives and relatively few false positives, that can indicate a threshold set too high, missing positives to avoid alarms. The exam may describe tuning decisions or may show before and after matrices, and the correct answer often involves adjusting thresholds to shift the exam may describe tuning decisions or may show before and after matrices, and the correct answer often involves adjusting thresholds to shift the balance between precision and recall. This is important because classification is not always a fixed label problem. It often involves choosing how cautious or aggressive the system should be. When you read matrix patterns as threshold behavior, you stop treating the model as a static object and start treating it as a decision policy. That is exactly how DataX frames many scenarios, because the exam is measuring whether you can align the policy with consequences. When results look impossibly perfect, such as near-zero errors across both classes in a realistic scenario, you should become suspicious of data leakage because the exam rewards that skepticism. Leakage can occur when information from the outcome leaks into the predictors, when the same entity appears in both training and evaluation in a way that violates independence, or when pre-processing uses future information. In classification, leakage often produces evaluation metrics that look almost too good to be true, especially when the real-world problem should be messy and uncertain. The exam may describe a sudden jump to near-perfect performance and ask what concern applies, and the best answer is often to investigate leakage or evaluation contamination rather than celebrating success. This is consistent with the auditor mindset you have developed in earlier episodes, where you assume evaluation can be misleading until conditions are verified. DataX rewards this caution because it reflects professional integrity in model validation. When you treat perfect results as a warning sign, you will avoid choosing answers that incorrectly assume the model is ready for production. Evaluation focus should be chosen based on harm, and the exam often frames this through domains like fraud, safety, or churn where costs are asymmetric. In fraud, misdetection can be costly, but false alarms also cause customer friction, so you must choose based on which cost dominates and what mitigation. In fraud, missed detection can be costly, but false alarms also cause customer friction, so you must choose based on which cost dominates and what mitigation exists. In safety contexts, missing a true hazard often dominates, which pushes you toward recall and sensitivity even if precision suffers, though you still need practical. In safety contexts, missing a true hazard often dominates, which pushes you toward recall and sensitivity even if precision suffers, though you still need practical triage. In churn, interventions have costs and opportunity costs, so precision can matter if incentives are expensive, but recall can matter if losing customers is the bigger pain. The exam rewards answers that match the metric emphasis to the scenario's cost structure rather than giving generic advice. This is also where you should consider whether the model's outputs drive automatic actions or human review, because that changes tolerance for false alarms. When you align evaluation with harm and operational workflow, you will choose metrics that reflect responsible policy rather than simple correctness. When you align evaluation with harm and operational workflow, you will choose metrics that reflect responsible policy rather than simple correctness. Calibration is a subtle but important concept, and DataX may test whether you recognize when calibrated probabilities matter more than raw classification labels. A classification label is a yes or no decision at a chosen threshold, but many business decisions require knowing how confident the model is, not just what side of the line it falls on. If outputs are used to prioritize work, allocate resources, price risk, or decide intervention intensity, well-calibrated probabilities can be more valuable than a single label. The exam may describe decisions that depend on ranking or on expected value, which is a hint that probability quality matters. In those scenarios, a model that produces accurate labels but poor probability estimates can lead to suboptimal decisions because it misrepresents risk levels. When you recognize calibration as a decision support requirement, you can choose answers that emphasize probability interpretation and threshold selection. When you recognize calibration as a decision support requirement, you can choose answers that emphasize probability interpretation and threshold selection rather than treating classification as purely categorical. DataX rewards this nuance because it reflects mature understanding of how models are actually used.
A reliable memory anchor is to keep predicted versus actual straight and to stay consistent about whether you are thinking in terms of rows or columns when interpreting a matrix.
Different sources arrange confusion matrices differently, which is why the exam can feel tricky if you rely on a single visual habit.
The safe approach is to define what predicted positive means and what actual positive means, and then build metrics from those definitions rather than from layout assumptions.
Precision is anchored on predicted positives, recall is anchored on actual positives, and keeping those anchors prevents many mistakes.
This is especially important under pressure because confusion matrix questions often include distractors that depend on you swapping denominators by accident. When you use the anchor to keep predicted and actual consistent, you can compute or reason about metrics correctly, even if the matrix is presented in an unfamiliar orientation. Consistency is your advantage here because the exam is testing careful reasoning, not memorized visuals. To conclude episode 13, speak the matrix insights aloud, and then choose one metric because that exercise forces you to connect counts to consequences and select what matters most. Start by describing where the errors are concentrated, such as whether the model is producing many false positives or many false negatives, because that immediately tells you the operational pain point. Then name the dominant harm in the scenario and tie it to the relevant metric emphasis, such as precision for reducing false alarms or recall for reducing misses. If the scenario calls for balance, explain why both kinds of errors matter and why F1 score is a reasonable summary while still acknowledging that it is a compromise. Finally, check whether the scenario implies a need for calibrated probabilities rather than just labels, because that can change what good performance means. When you can do this smoothly, you will handle confusion matrix questions with calm, structured thinking instead of getting trapped in denominator confusion under time pressure. Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.